3-point charges are placed at the corners of an equilateral triangle of side L as shown in the figure. We have to verify various statements over here. Now before we proceed, let me draw an equilateral triangle of length L. Okay, let this point be equal to A, let this point be equal to B, let this point be equal to C. There is a positive Q charge, there is a positive Q charge over here, and there is a negative 2Q at the top. Okay, and there is a L at the bottom. Okay. Now first thing we have to verify is, first of all we have to verify the potential and electric field at the centroid. The distance of the centroid from any one of the points for an equilateral triangle is equal to L divided by 2 root 3. Okay, so the distance from any one of the charge over here will be equal to L divided by 2 root 3. Okay, which will remain same. So let us first find out the potential. The potential is since it is a scalar quantity, the potential will be the addition of all the individual potentials, which is equal to K Q divided by, let L divided by 2 root 3, let this be equal to R. Okay, R plus KQ divided by R due to the second charge. Now this is due to B and C, and due to the third charge it is equal to minus K2Q divided by R, since the charge is equal to negative. So if you calculate this value, it will come out to be 0. So the option number A is correct, that the potential at the centroid will be equal to 0. We have to find out the electric field. Okay, we have to find out the electric field. Now in order to calculate the direction of the electric field, understand that in order to calculate the direction of the electric field, I will erase this potential first of all. Okay, so in which direction will the electric field act? Okay, in order to find out the direction of the electric field, for the negative charge along the centroid, the electric field will act in this direction. Due to the positive charge, it will act in this direction, and due to this positive charge at B, this will act in this direction. Okay, now what is the angle between them? Okay, what is the angle between them? Okay, as I can clearly see that, the total angle over here will be equal to 60 degree. Okay, will be equal to 120 degree. This angle, any angle if you calculate, it will be equal to 60 degree. Okay, any angle you calculate, it will be equal to 60 degree over this part. Okay, so if you can see, okay, let the electric field due to the C part, let it be equal to E1. Okay, so the E1 acts over here. Okay, so the E1 sin 60. Okay, E1, this is E1 sin 60, and due to the other part, let it be equal to electric field be equal to E2. So this is equal to E2 sin 60. So E2 sin 60 and E1 sin 60 will get cancelled out, but in the direction of A, that is equal to E1 cos theta and E2 cos theta, they will add up. So the total electric field at this point will be equal to the electric field E1 cos theta plus E2 cos theta. The magnitude of both of them will be equal to same. Okay, plus the electric field due to the third part, that is due to the negative 2 charge. Okay, so whatever is this value, all three of them are in the same direction, so they will not get cancelled out. Okay, so they will not get cancelled out. So the electric field at the center will not be equal to 0. So option number B is incorrect. Let us find out the dipole moment of the system. In order to find out the dipole moment of the system, okay, either option number C or D are correct. Okay, in order to find out the dipole moment of the system, what we do is, it's this is a positive Q charge and this is a positive Q charge. I will divide the negative Q charge into two parts, that is negative Q and negative Q. So the first dipole looks somewhat like this in this direction. The first dipole looks somewhat like this in this direction. Negative Q, positive Q, and the dipole moment will go from positive Q to the negative Q. And the second dipole looks somewhat like this. This is equal to negative Q and this is equal to positive Q, and the dipole moment will be in this direction. Okay, I have divided the negative 2Q into two parts, that is equal to negative Q and negative Q. Okay, so I am getting two dipoles, and the angle between them is equal to 60 degree. Since it is an equilateral triangle, the angle between them is equal to 60 degree. Let us find out the dipole moment due to any one of them. P1 will be equal to Q into L. Simply it will be equal to Q into L. Okay, so now the total dipole moment of the system will be equal to root of, now which will be equal to P2. Okay, because the charges and the length are same. So basically the total dipole moment will be equal to P1 square plus P2 square plus 2 P1 P2 cos theta. Okay, and the angle between them is equal to 60 degree, which is equal to root of, now P1 and P2 are same, which is equal to P1 square plus P1 square plus 2 P1 square into cos 60. Cos 60 over here is equal to half. Okay, so instead of cos 60 I can simply write it as half. So 2 and 2 will get cancelled out, so it will be equal to P1 square plus P1 square plus P1 square, which is equal to root 3 P1, and P1 is equal to Q into L. So basically it is equal to root 3 QL. This will be the dipole moment of the entire system. Okay, which is equal to option number D. So the correct answers are option number A and D.